Vets. Go. This one should take you about 2 minutes. Tops, because there's lots of numbers. Right now, if you don't show it out, okay, so you have to show the work out. If all you do is say that that equals 1.6, you're not going to get full credit. So you have to show what you're doing. Okay, so it says that X represents the number of telephone lines in use by the technical support of a software manufacturer at noon each day. So I know this didn't tell me to interpret it, but could you interpret it? Let's go ahead and just practice that skill. So write the interpretation of what 1.6 means, just for some good practice. How do you have to start it? In the long run, or what were you? After many, 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 many repetitions. Okay. Or in the long run, the expected number of telephone lines in use at noon is 1.6. Okay? Okay, so if you said the average telephone lines in use at noon is 1.6, will that get you credit? No. Okay? What did I fail to say in that second part? The long run. Okay? The many, many, many. So if I said the average number of telephone lines in use at noon is 1.6, or if I just said the expected number of telephone lines in use at noon is 1.6, I have that wrong because I left off that long run part. So you have to have it if you want that point. Okay? Now, this one didn't tell me to interpret it, but interpretation could definitely be on the test. Okay. Now, I wanted to show you, before we move on the calculator, how we can do this. In your list 1, put your X's, and in your list 2, put the probabilities. A lot more complicated. in my list, I'm going to just clear off my home screen. And I'm going to go to stat, and I'm going to calculate some statistics. But now, I want to do it with what? Two variable. Hold on. Is it one variable? Sorry, it's still one variable because it's still, sorry, we only have one variable going on, not two variable, but our frequency is the probability. My bad. Okay. So we still want to calculate, we just have one random variable, so sorry. Okay. So we have one random variable, but in the frequency list, we're going to put list 2. And then we can calculate it. And here I should get out. Why is that not giving it to me? Did I put it in wrong? I put it in wrong? Why didn't you guys tell me? What did I put in wrong? Oh, it says 1 there. Okay, thank you. I love standing up here looking like a fool. Alright, so let's see. So, stat, now this should work. Calculate one variable. There we go. Okay. So here it gave me my expected value in my X bar. And here it actually gave me the standard deviation. You guys, unless it isn't multiple choice, you have to show the work, okay? Or you don't, like, you can't just put the answer from here. So unless it's a multiple choice, you still have to show out the work. But can you go and check that you did it the right way? Yes. Okay? Absolutely. Okay. Just wanted to show you that. Okay, let's read B, Brenna. Class records. The staff of the topical support center randomly selected 20 days and found that an average of 1.25 telephone lines are used at noon on those days. The staff proposes to select another random sample of 1,000 days and compute the average number of telephone lines that were in use at noon on those days. How do you expect the average from this new sample to compare to that of the first sample and justify your response? Okay, so they said after 20 days, they got, this is the expected value. What do we expect to happen after 1,000 days? Closer to 1.6. Do you agree? We're doing more and more and more trials. Because the more repetitions and the more trials, what are we decreasing? The variation, okay, that variability. And that would be our justification. As we increase our sample size, as we increase the N, then we're decreasing the variability. Okay? So we're going to get closer to the expected value. Does anybody not understand that? Okay. So that would be for that one. Andy, I'm going to make you tell me exactly what you wrote when you're ready. Alright, repetitions, the variability will decrease. Sorry, I've abbreviated a lot so I can keep up with you. Okay, so she said the average is closer to 1.6 because as we have more repetitions, the variability will decrease. Do you like that? I do too. Anybody have anything they like better? Okay, so that sounds pretty good. Alright, C. C is a little bit weird, okay? It's like, hey, I'm going to ask you something in a way you've never seen it. And that's okay. You're going to have the skills and they're going to do that to you. So they said the median of this random variable is defined by any value x such that x is less than or equal to little x is greater than 0.5 and x greater than or equal to little x probability is greater than 0.5. Okay, so we have it. Basically, do you know what this is trying to tell us? That the median is located where? It's just trying to tell you where the median is located. At the 0.50. So if I was to keep adding on, this is like 0.35. This would be add on. 0.55, 0.7, 0.85, 0.95, and 1, right? If we were to kind of do the cumulative. So they were just saying, determine the median. So where is the median going to be located if they're telling you that basically 0.5 is where the middle is? At 1. Okay? So the median is here at 1. That's all it's kind of telling you. And you could draw a histogram too to kind of see this if you wanted to. Okay? So that's where the median is going to be. You can see that by that accumulation. So that's part C. And then I hope and pray you all remember this from part D. I'm going to cross my fingers. You're going to talk about D. But it says comment on the relationship between the mean and the median relative to the shape of the distribution. Just the way you guys talk when you're ready and you're like, we got you, DeRose. We're not letting you down on this. Let me know. I know you remember this. I know you do. So what was the mean? 1.6. What was the median? 1. So the mean is what? Greater than the median. So if the mean gets pulled by the skew, so this would mean that I am skewed right. Did y'all get it? Did you remember that relationship? Okay. All right. So that's actually the end of what we were doing yesterday. Okay, remember how yesterday we barely got through that because we had a lot of chattiness? I remember that yesterday. I know, right? But like all of those 30 seconds to minutes added up and we didn't get through that last example. So now we had to file it onto today too, which is going to kind of take a lot for notes today. So if you can, please try to keep the chattiness, the stuff that's not about stats until after stats. I would appreciate it, okay? And that way we have more content. Okay, so today we're going to continue on with what we were doing, but we're going to talk about that linear transformation, when I multiply or divide by a constant. And we've already been discussing that from before, like what happens to the center. So if I multiply or divide, right, what happens to my old center if my center is C? What would I do? It gets what? The center gets, does it shift if we multiply or divide? It shifts, okay? So the new center would be what? If this one was C times whatever, let's say we multiply or divide by B, okay? Then that would be C either multiplied or divided by B. What happens to the shape? Stays the same. Right. Now the variability may increase or decrease, but if it was skewed right, it stays skewed right. If it's normal, it stays normal. Okay? And again, that's what we're going to start here in a second. That variability, or the spread, what happens? If S maybe was my spread, what do I do to that? Multiply or divide by not just B, but the absolute value of B. Okay? Sorry, that was kind of hodgepodge of me thinking through. But that's what we have learned before. Okay? And that's what we're going to kind of talk about, and then as well as adding or subtracting. So if I add or subtracting, tell me what happens to the center, the shape, and the spread. So let's say I add or subtract by some constant, again, C. What happens to the center? Yeah, we're going to add or subtract the C. What happens to the shape? Same. And what happens to the spread? Same. Okay, so when I add or subtract, the only thing that changes is the center. Okay, so this is example. Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. I kind of see that going on. Define X as the number of passengers on a randomly selected day. P charges $150 per passenger. The random variable C describes the amount P collects on a randomly selected day. Compare the shape, center, and spread of the probability distributions. Okay, well, if this is where I started, can you tell me my mu sub x and my sigma sub x? And let's go ahead and just practice that skill in our calculator really quick again. Let's see if you all can find it just from the calculator. 150 per passenger. So basically what are they doing with every X value? They are multiplying it by 150. So they're saying that they are going to multiply by 150. Let's just make a new distribution really quick. And let's go find what that would be. So now let's do the money and the probability still. So on 2 passengers, how much money would he collect? 300, and the probability would still be the same. That's still just for 2. For 3, I would be at 450. For 4, I am now at 5. And now just go change your X list and find the mean and the standard deviation for this guy now. See if you get that. Yes? Okay. Now, did I have to go and make this new thing? Did I have to make this? I did it so you could actually see what we're talking about. Because before they said that we are basically just multiplying by 150. And we know from up here that when we multiply, okay, so when we multiply, we know that the center is multiplied and the spread is multiplied by the absolute value. Well, down here, this guy is my center, right? And this is my spread. My standard deviation is the spread of variance. So if I square it, that is variance, right? So all I had to actually do was take that 3.75 and multiply by 150. And that would have given me the answer. All I actually had to do here was take that 1.090 and multiply by the absolute value of 150, which is 150, and that would have given me my answer. And that's what this is kind of helping you see, this relationship between the transformations on a variable. And what about the shape of the two? They would be the same. All right. A large auto dealership keeps tracks of sales made during each hour of the day. X is the number of cars sold during the first hour of business on a randomly selected Friday. And it told me that I have a mean of 1.1 and a standard deviation of 0.943. And you can check this if you want, but we're okay. I know how to do it, yes? Suppose the dealership's manager receives a $500 bonus from the company for each car sold. Okay, so this is part 1. Find the mean and the standard deviation of Y. So what is this telling me to do? Each car sold is telling me to multiply by 500. Yes? So this is just saying you're going to transform by multiplying by 500. So now that's what Y is. So now I can find mu sub y and sigma sub y. Can you go find those two values? Oh, no, those are both y's. Oh, thank you. Is everybody okay with that? Okay. So then they're saying now, hey, to encourage customers to buy new cars, the manager spends $75 on coffee and donuts. If you can go. Okay? So now we're saying that this is the profit T. Profit T. Okay. Okay. So on a randomly selected Friday. So this is the bonus earned minus the $75. Because he's only spending it once, right? So he's only taking out 75. It's not like multiplied by each or anything like that. So this guy right here is just a minus the 75. So now it wants the bonus earned. So again, the bonus earned was a multiplication of 500, and then the propaganda stuff, whatever he's doing, is minus the 75. So how are we now going to find mu sub t and sigma sub t? So we still are going to start with our original. And then we're going to go ahead and, not yet, multiply by the 500. And then does the center change when I add or subtract? Yes. So I minus the 75 here. Which gives me 475 is the expected profit here. Okay, the T. Expected net profit. The sigma, you take the original, and we still are multiplying by his bonus. Do we subtract the 75 from there? No. So this is still just that guy right there. Okay? Because the spread doesn't change when you add or subtract a value. That stays the same. Only the center changes when you add or subtract. Okay. Try this one. This should take 2 to 3 minutes. Try this one with your buddies. Okay, what do you think here? Yeah, we are multiplying by 12. So if we multiply, do we multiply both? Yes, both of these guys get multiplied. Okay. That's hard to see. Okay, back to Pete Sheeps. Consider Pete Sheeps scores again. We define C as the amount of money Pete collects on a randomly selected day. And here we go. It costs Pete $100 per trip to buy permits, gas, and a ferry pass. The random variable V describes the profit Pete makes on a randomly selected day. Okay, compare the shape, center, and spread of the new random variable V versus that random variable C. And if you get completely lost, sometimes you can start with just making a whole new distribution. Think, what would I do to that 300 to put the new one there I just got? What would I do to the 450? What would I do to the 600? So think about what you're doing. How are they trying to confuse you? Per trip is trying to confuse you. Because what are you just doing to each of these values? Subtracting 100, right? That's if you had 2 passengers, still 1 trip. That's when you had 3 passengers, still 1 trip. That's when you had 4 passengers, still 1 trip. Yes? So what are you doing to all of those values, basically? Subtracting 100, okay? So this right here is subtracting 100. So go tell me, and we already found that one, right? Oh, you get them. So this one right here. What they had is that 550 and hold on, no, that was the wrong person. 562 and 163.50. That's what that guy was. So we already found that a couple examples ago. So now it wants you to find u sub b and sigma sub b. You can state these guys and then just tell me the shape. I mean, if for this one, if this is going to be on an AP test, just please write sentences. Okay. Or your actual test, yes, please. Okay. So on this guy, when I am subtracting, do I subtract from the mean? Yes. When I am subtracting, do I subtract from the spread? Stays. So if I was to write my sentences, I would say the mean is lowered by 100, the spread stays the same, and the shape stays the same. Okay, so those are the basics. Now we're going to take 2 really quick. Sorry, I can do this. Okay. So if y equaled a plus bx, basically, the mu sub y is the a plus bx, where the sigma of y is the absolute value of bx. Here, we'll put mu sub x times mu sub x times sigma sub x. Sorry. There. Okay. So basically it just says the mean you multiply and you add by just what you had. The standard deviation you can only multiply by the absolute value. So if you like looking at it like that, that's all it's saying. I don't know. If you like it. Okay, so the mean of the sum of random variables. Okay, so if you have two now random variables, let's call them x and y. So you have two random variables. And we're going to let t equal x plus y. Then mu sub t, the expected value of t, all you have to do is add those two together. Okay? The only thing you have to know is that they are independent. If they don't tell us they're independent, we're usually going to just have to say, assume independent when we're talking about the variables in order to do this. So again now, if I'm talking about the variance of the sum of random variables, so the whole t, again, is that x plus y, okay? The sigma sub t is a little bit more complicated. What's wrong? Okay. So the sigma sub t, you're going to have to take the square root of the sigma sub x squared plus the sigma sub y squared. Okay, so highlight these two formulas so far. Get these two formulas highlighted. Okay, so let's look at this guy. Let's say that Pete has some competition and it's Aaron's Jeep Taurus. You have Pete and Aaron. Assuming independence, what is the new standard deviation for Pete and Aaron? Let's do the new mean and standard deviation. Huh? Oh, we just did the standard deviation. Okay, sorry. I know. Sorry, that. Oh, okay, I got off. This is the standard deviation. Sorry. Oh my gosh, you guys, I got off. Okay, so this deviations squared. Okay? Okay. Thanks, Jen. I think it just got off a little. Okay. Better? Okay. Just want to get to the bottom. Good now? Yes. The standard deviation squared is variance. Okay? So just in general, you guys, the standard deviation squared is variance. Just the sigma is your standard deviation. That looks really funny. I'm trying to like, I don't know, however. Okay, but the standard deviation squared is variance. Just the sigma is just standard deviation. Okay. Okay. Okay, so on this one, let's find the mean and the standard deviation. So assuming independence, what's the new mean and standard deviation for Pete and Aaron combined? What do you want to call this? Like T? Let's call it T. Together. Pete, heart, Aaron. We could call it heart. No. Come on, let's just do it heart. Can we call it heart? Let's call it heart. Okay. So mu sub heart and sigma sub heart. What would those equal? Okay, so the averages, all you have to do are add together. That's all. The averages are easy. Just add them together. Done. Okay. The standard deviations are where you have to take the square root of this guy squared plus this guy squared. And make sure you can all put it in your calculators okay. And I got out 1.44 approximately. So see if you're okay putting that in your calculator. Is everybody okay? Okay, let's look at this next one. Let's see what's off. Okay, that's what I should title this one. What's off? Okay, something is not right here for us to do this job on. So let's think through. Because I know we've kind of got a lot in our heads right now. We're tired. It's 4 o'clock. Okay? It looks like it's going to be just a really easy, simple little thing. But what did they forget to tell us? Who said that? Jenna! What did they not tell us? Hey, are they independent? independence. Independent. Okay, so what did they call this? B? No. What did they say? You want to call it T? Okay. So we can do the mean. But we can't do the standard deviation. Okay. Let's check your understanding with your group. And I know I typically don't do these, but I feel like this is good practice. And while you're doing that, I have a little treat for you all. It is a dark chocolate espresso bean for your Valentine's Day treat, if you would like one. Okay, now check your understanding. Chew it. Yeah, you just chew it.
Put it under your eye. Later you get another one and you pretend to eat it. And then say, what's it? Ew. I just like this.
Okay. Andy, do you like it?
That's called being ungrateful.
I told the company I was actually very nice. Oh yeah. Okay, see if you get these guys. If you haven't got these yet, then you are behind. Okay, so see if you get those two values. You should be through this. Okay, everybody ready to do number one? Lucas, what'd you get for number one? Use of T. 1.8. Okay. So Jenna, can you interpret that? What do we always have to start with? Perfect. I couldn't have said it better. You were. Okay, 2. Compute and interpret the standard deviation of x plus y. Assuming they're independent. I love that you all paused, though. It's like my sweat emoji. Can I go? That's my sweat emoji. You know how they're like, whew. Okay. So I got 1.14. Okay, for time purposes, we're just going to say what the interpretation is. Okay? Most of the cars will be within 1.14 of the expected value of 1.8. Okay, so most of the cars shipped and leased will be within 1.14 of the expected value of that 1.8. Okay? Or you could kind of think of it like an interval and say that most of the cars will be between this amount sold and leased on the random Friday, blah, blah, blah. So like if I talked that this is my mean, if I add 1.14, it takes me here. If I subtract 1.14, it takes me here. So I know most of the cars sold and leased, right? The typical amount of cars sold and leased on a random Friday at noon is between those two values. That's a pretty easy representation too. Okay, so here's where it gets a little complicated, you guys. Number 3. The dealership's manager receives a 500 bonus for each car sold and a 300 bonus for each car leased. Find the mean and standard deviation of the manager's total bonus fee. So I'm going to tell you the values you should get. This gets a little complicated. See if those make sense. I think the T isn't going to be too complicated, or the mu isn't going to be too complicated. The sigma is what is more challenging. The answers. Like right how you got them. Okay, so for this total, did you take the original, which was what for sold? Oh, sold was 1.1, and I multiplied it times the bonus for each car sold, because that's a multiplication, and that's a multiplication, yes? So I multiplied it by 500, and then I can add on the least, which was 0.7, and I multiply it by the 300. So that gave me 760. Okay, so this is the tricky part for the sigma. First, think of the sigma for the sold one with the money, the sold money. So the sigma for the sold money would be what? The 0.943 times the 500. Yes? And the sigma for the least with the money would be the 0.64 times the 300. So go find those two values. 471.5. 92. Okay. So those are like the two standard deviations. So now when I go find this standard deviation of B, which I want these guys total, I'm going to have to do the square root of this one squared plus that one squared. See how that's a little bit of the procedure? Steps involved in that would make it a little bit more complicated. Which we said 509.09 is what I got. Approximately. Okay? Okay. So again, let's say now that I have this D that is x minus y instead of plus, then the mu sub D is just the mu sub x minus the mu sub y. It's very, very straightforward. And here, if I'm going to do the variance, I have to assume what, first off? Okay, so we have to have independence. Then this guy, sigma sub D, and you're going to be like, what? Oops. Get all my variables right. Guess what goes in the middle? It's not. It is always a plus. So even when that D equals the x minus the y, okay? Sorry, this is the standard deviation. I know that says variance. Variance, we just square both sides. I did that last time too. I just jumped right in. Okay? But it is always a plus. Star this, make a big note. Standard deviation, when you are combining, it is always a plus. Mean is plus or minus. Mean just goes with the flow. Mean we never overthink, it's just what you think it is. Okay? It's very intuitive. Standard deviation guide is where all of the problems begin. this really quick. Same thing. Same thing. So now mu sub t is 1.1 minus 0.7, which is 0.4. That is supposed to say, gosh dang it, I had it here to fix that too. That's supposed to say minus. Okay. And we're just going to do that one now, and then we can do some of the good ones. So go find x minus y, the standard deviation of x minus y. So that mu sub x minus y, not mu, sigma sub x minus y is still the square root of the first one squared plus the second one squared. So it's the exact same thing as what we found before. And it kind of goes into that role of remembering how we're always doing the absolute value with the variance. We're never doing the negative. We're keeping variance positive. Okay? So it goes all into that lump sum of why we can't have a negative. And you guys, like, think about, like, if you put a minus here, and this value ended up being bigger, what would you have inside of the square root? Can that happen? No. So just another way to remember that when you got the square root, you only can have the plus right there. Okay? Okay, so let's look at Mr. Starnes. This is fun now. Mr. Starn likes between 8.5 and 9 grams of sugar in his hot tea. He's very particular. Suppose the amount of sugar in a randomly selected packet follows the normal distribution. Oh, what word did they just throw out there at me?
Normal.
Okay, I'm hearing a normal distribution. We'll do our little, what is that? Pink guy? Oh, that is horrible. I don't know. How do you do it? Okay. So that's my think guy of the normal, okay? So when I see that normal, I have my little think guy of the normal graph. Okay. Anyway, with a mean of 2.17 and the standard deviation of, oh wait. So that's the information that I've got so far. If Mr. Starnes selects 4 packets at random, so this is the mean of 1 and the standard deviation of 1. What is the probability his t will taste just right for him? So what am I going to have to go find? I'm going to have to find the mean of 4 and the standard, the standard deviation of 4. Go find that for me first. So you could think of it 2 ways. You could think of 4 times that amount, or you could think that you are adding this amount 4 times. So you could think of it as plus, 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 or you could think of it as 4 times. Regardless, you should get the same things for these 2. Did everybody get that? bit harder now. Huh? Did I write it wrong? So we have to do, you could think of it as like 0.08 squared plus 0.08 squared, right? Plus 0.08 squared plus 0.08 squared. And then that's squared, right? So like that gets rid of it when I take it. Okay? So okay, so this would be the square root of 4 times the 0.08 squared. What does this mean? So that should be the right answer. So you're saying that we could just do 4 times that?
I thought it was a one variable. Like two variables. Yeah. You know what I'm saying? Like x squared plus y squared. It's like just one number. So like you
Yeah, so this is how you have to do it. I don't know that I'm following things very well right now. I'm not close. This is how you have to do it. I'm so sorry. So this is just like what we were doing, you guys, like this one. So this is our formula. But we're just expanding it now 4 times.
so you can still that even if it's one variable.
Yeah,
All the same.
yeah. So we're just expanding it out from 2 things to 4. Okay. Okay, so that gave me my 0.16. So now let's actually get back to the fun part of the problem. It says, what is the probability that this t will taste just right? So we're going to go back to this normal distribution. And we said we have a mean of 8.68. And then our standard deviation is 0.16. So that would take me up to 8.84. And back to 8.52. And he wants it to be between what? 8.5 and 9? Looks like we're going to get, well, maybe closer. Looks like we're going to get a pretty big probability. It looks like he's going to usually be happy. So what's the probability that 8.5 is less than x is less than 9 here? And what am I going to define x as? Did we already do that yet? So X is the amount of sugar in 4 packets. So do your normal CDF, and what do you get? $84.7, so about 85%. So is he typically pretty happy?
Yeah.
Yeah. Oh, I took my mean of this guy and I added on the standard deviation, and then I subtracted the standard deviation. Yeah. Okay, do you all remember how to do the normal CDF? Okay, we have one more we're going to do together. Does anybody need help remembering the normal CDF? Yes? Okay, last one, guys. Last one.
Sure.
Okay.
Suppose that the height of a male speed gator follows a normal distribution with a mean of 70 inches and standard deviation of 3.5 inches.
Okay, let's pause. Can we write that information down? Okay, and pause.
And suppose that the height of a female speed gator follows a normal distribution with a mean of 65 inches and a standard deviation of 3 inches.
Okay, pause. And what else am I probably going to see? We're going to do our little what? Okay, so we're a better think than me. Okay, but there's my thinking guy. I wish that this had emojis that I could just put. It'd be so much better than me trying to do it.
We'll design that out.
Okay, thank you. Yes, please. Okay, I always wish that they had it on the keyboards here now, because it's just like so much of like, really dope or whatever. Okay, so that's what we're thinking. Okay, so now here's like the little, this one's a little bit different, okay?
But what's the probability that a randomly selected male speed gator is taller than a randomly selected female speed gator with boobs and hair?
Okay, so how am I going to say that? The probability that the male is what? Greater than the female. But this one you're like, huh? Right? We haven't seen anything like that. We don't quite know what that means to do. So we're gonna just manipulate it a little bit by subtracting over the female. And what's left now on this side? 0. So we're basically now making this guy our new variable. We can call it the difference. So when is the male minus the female greater than 0? So now we are going to need mu sub d, and sigma sub d in order to go find that probability. Does that make sense? Cassie, is that confusing? Emily? So go find those two values. So see if you get these two values. I would show your work in your notes so you know how you got them. Those are the two values you should get. And if you go get those two values, see if you can finish the problem now. So what type of variable are these guys when we're using the normal? Continuous. When you're using those charts, what kind of variables are they? Discrete. Okay? So depending on if we have a continuous or a discrete variable is why we're using either the normal or the t-chart thing. Is everybody good with those two values? Okay, can you go and set up your normal graph and finish? Define your variable, right? All that fun stuff. That point of inflection is that one standard deviation. And you guys, I actually had out, if you kind of see, I built in 3 review days in case we didn't get through stuff. But I like that we got through it all, because I was like, oh, I have to move some of it here. But that's really good that we got through it, so that way you'll have more time to review it before the test. So you can see I filled that in yesterday if we had to have it, but I'm glad we didn't. Okay. 6-1 quizzes tomorrow. So some of you guys needed to talk with me about some things. Distance.
That's the, yeah. Okay, so you said we can, like, but you keep us wrong answer to the dress, please. I know. So just go fix it. Okay. So, got that? Yeah. So, show me where it's probably best. Where it's best. So it should be there. Show me where it's at. Yeah, so that whole little okay. So this right here, all the things that are going on is the intersection of those two. So that's why we got it. Yes. That's okay. But yeah, so all of them as a 160. So that's okay. So yeah, you were trying to do something with it, but mutually exclusive, they have nothing in common. But you just told me that's actually they have something. So tell me mutually exclusive or exclusive. Can they overlap? Yes. Okay. But what's the problem with the A deal there in their heads? Like, given this information, oh, that's it. So I know if I find that, I find that. That's why I'm just looking at the intersection. So we find all of our totals.
There you go.
Just divide by 2. Yeah. Okay. Okay. So, what did I get? Plus 2, I think. Yeah, I did. Here's Kelly.
big yeah. Right. You're joking. That's get it right. Days. Let's talk so we can go to American. I said, really?
So, oh, hold on. You don't want to take me. Sorry. So, it's 28. So you're going to have to take 28 numbers and how many of them are left handed. Basically. We're trying to be close to
Right.
right? Okay. So it was like this part that's throwing you off. I think of course. Okay. But it is nice because it's you can take this one.
My dad's a good guy. Yeah, we can find a crowd. So, you know. Happy Valentine's Day.
Sass, I have it if you want to come get it. Okay, I'm just putting them out like Alright. See what you got.
What, am I gonna stab a rock?
Okay. Now that I can see, I'm correct. Stop. Okay, what?
Walmart.
I don't know what everyone else has. There was something, yeah,
Someday, okay.
one, but they're not, they have the right purchase. Everybody had that clay knife, just look up. So, I went to right there, but I was like, well, she was. Okay. And you had labeled, you're telling me you had labeled those first time around?
Why? Your lame sauce.
I mean, I know that's what the numbers we had. That's, I don't know if they were labeled. Okay. Why is it awesome here? See that one, these points?
So wasteful.
Last ones that we talked to. That's not the right one. Okay. You too. Sydney, I have your 5-3 quiz too. Okay. Can you get that from me? Emily, were you here for that?
I was not.
Okay. I didn't put anybody's name.
I didn't have it in the forms.
Here you go, Sydney. Sydney, can you? Yeah.
Are you going to be in